Private Key Java Web Token Authentication. Let me be honest with you, for the first time when the client asked me to configure this, I had absolutely no idea what I was doing. I still remember staring at the requirement and thinking, I did configure client secret before, which is straightforward, but what is this private key JWT? I didn't even know where to start. So I spent hours going through the documentations, random community post and blog post, but nothing gave me a complete picture like from start to end. That is frustrating, trust me. But once I figured it out, everything made a lot of sense. So I thought someone out there who is struggling and figuring this out, why can't make a video for them? Which I wish I had back then. So we are here. If your clients asking you to configure private key JWT authentication for security, for compliance, or to adopt to the latest approaches, this video series is for you. No prior experience needed. I will cover each and every step, literally each and every step for you. So let's get into it. Here is our plan. Now we are going to divide the entire process into 3 videos. In part 1 video, we will register ServiceNow in Okta, generate public and private keys, convert the private key into Java KeyStore certificate, which is needed for the ServiceNow configuration. In the second video, we will cover creating X.509 certificates, JWT provider, JWT keys, application registry and REST message, and anything else that is needed to get the access token in our hand, all the ServiceNow configurations. So once we have the access token, in the video 3, we will do integration between ServiceNow and Okta, a real life scenario, while fetching the data from Okta and updating the data in Okta. So the first thing now we have to do is jump into Okta, and this is my Okta personal developer instance which I registered. And here let's go to applications, click on applications, and let's register a new ServiceNow application into Okta. Here I'm going to select API services. Why? Because ServiceNow is going to talk to Okta as a machine, not as a human logging in. Just server to server, pure API communication. So let's hit on next. App integration name, just give the name that is related to your project. Here, let me give it as ServiceNow PDI Dev Connect, and let's hit on save. And here, if you scroll down, and here is where you may get a little confused, because previously we used to do client secret and we copy the client secret, unconfigured client secret and client ID. But now we are going to do different, which is we are going to select public/private key as a client authentication. Before doing this, let's try to understand a small difference between the client secret way of authentication and the public/private key way of authentication. So for this, I'll just jump onto my whiteboard, and here we'll try to understand it very simply. Let's say these two, this is our client server, and this is our authorization server. In our scenario, this is nothing but ServiceNow who is requesting for the access token, and here it is Okta. Okay, so ServiceNow in general sends a request message for the access token, and to authenticate itself that it is the legitimate client who is requesting for the access token, what ServiceNow sends is the shared password or the shared secret, which is client secret, along with the request body. Okay, now since this client secret is sent along with the request body, the authorization server will check the client secret, compare with the client secret it has got, and it will return the access token if it is matched. Almost similar, but in the private slash public key way of getting the access token, the difference is instead of shared password or shared secret, now the client will have something called private key, and the authorization server will have something called public key. The similar way, here also a request message for the access token will be sent, but along with the message we are not sending client secret. Okay, instead we will encrypt this with the private key. So what's happening here is this will be encrypted with the private key, and once it is received, the authorization server will decrypt it using public key. So hence it will understand, okay, this request is coming from the legitimate client, and it will return the access token. Now the scenario, if this request message gets compromised, okay, if this request message compromised, now the third party can access the client secret and impersonate as ServiceNow and get the access token from the Okta, because they get the client secret if the message is compromised. But here, if the message is compromised, the third party cannot do anything because they do not have the private key and they do not have the public key for encryption or decryption, because they never left the server. They just encrypts and decrypts at the server level. In the message, we are not sending it, and this is the major difference that I see between these two way of authentication. If you understood that, awesome. Now let's get back into the Okta. Click on edit, go for public/private key and hit on save. Now before hitting on save, we have to generate the public key. So let's go to public key section and add key and generate new key. Here Okta will generate public and private key and keep the public key with Okta, and it will give the private key to us. So go to PM format and copy this, because once we hit on save, we cannot get that back. So Okta will only show that once. So once you copy, just click on done and save the key, and now you hit on save, and we don't need a client secret any longer because we are now doing public/private key way of authentication. So click on save. Now we have the app registered in Okta and public and private keys generated, and you can see the public key is being stored in Okta, and we have the private key which we have to configure this in ServiceNow. To configure this in ServiceNow, we have to convert this private key into a JKS file. Now you might have a question, why can't I directly upload this private key into ServiceNow? Why do I need to convert, right? ServiceNow Certificate Store doesn't accept a raw private key file. It only understands a specific format called JKS Java KeyStore. Think of JKS file as a digital locker that holds your private key and certificate together, protected by a password. So what we are going to do is take this raw private key and go through a 3-step conversion process. Let me show you how that looks like. In step 1, we will create a self-signed certificate. We will use OpenSSL to derive the public key from the private key and package it into a self-signed certificate. In step 2, we will create a PKCS bundle file. We will use OpenSSL again to package the private key and the self-signed certificate created in the step 1 together into one password protected container. In step 3, we will use Java key tool to convert the PKCS bundle into the Java KeyStore format, the exact format that is needed for the ServiceNow. Now, If you want to go deeper on what exactly a self-signed certificate is and what PKCS 12 means or how JKS works internally, drop a comment below and I'll cover all of that in a dedicated video. Happy to go as deep as you want. For now, we will follow these 3 steps and get exactly what ServiceNow needs. To make this conversion process easier, I have prepared a small document where it helps step-by-step instructions to convert the private key into JKS. This document has 2 sections. One is for the Windows and another for the Mac OS. Since we are on Mac, let's go to the section 2. These are the softwares that are needed for the 3-step conversion process. I already have these softwares installed. If you don't, just go through these URLs and install the latest version into your system. Don't worry, I will attach this documentation to the video description. You can access this file from the description. Once the softwares are installed, we have to verify whether the installation has been successful or not. So for OpenSSL, copy this command and open terminal and just paste. So here I can see that the software has been installed and the version is 3.3.6. And for the other software, which is Java Key tool, let me check whether that has been successfully installed or not. So no error, that means it has been successfully installed. We'll start with creating a folder where we can save all the certificates, all the PKCS file that is generated throughout the process. So the file name would be KeyStore work. So let's start with that. Let me open the file. Yep, KeyStore work. So now let's open the file and let's store our private key inside the file. Okay. So where is our private key? Here it is. Delete all these. So once you copy the private key, paste and Control X, save this file and enter. So if we go back to our folder, you can see the private key has been successfully saved into the folder. The next step would be verifying whether the private key has been successfully created or not via the terminal. So yes, I can see the private key has been successfully created. Now let's go and create a self-signed certificate. So the input here is the private key and OpenSSL will generate a public key and convert that into a self-signed certificate using this particular command. Let's go back to our terminal and execute that command. So no output, that means it has successfully created. You can verify that in the folder here. We can also verify this from the terminal by just copying this command and checking in the terminal. Okay, you can compare these results. We can see the issuer and the public key algorithm, and this is the expected output. So once we have these self-signed certificates, the next step is creating the PKCS bundle. This is the statement command, and here we can see the certificate created in the previous step. They are using that as an input, and output we are going to get the PKCS bundle. So the input is also going to be the private key. So the PKCS is going to be the combination of the certificate and the private key. So let's go to our command and terminal and execute. So we can verify this in the folder. The P12 bundle has been created, which is the combination of the private key and the self-signed certificate. So the last step, which is getting the JKS file. For getting the JKS file, this is the command. So Java key tool will execute this command. It will take PKCS file as an input, and it will get us the JKS format. And remember, this is the password for the container, and make sure you put a stronger password if you are creating this for your production environment. Okay, so we do not have the JKS file yet. After executing the command in terminal, you can see the file has been created successfully. And yes, we got the JKS file finally. This is needed for the next steps, that is setting up the connectivity in ServiceNow. And that's all for the part 1. To revise, we have registered our ServiceNow application in the Okta, set up the authentication as public/private key. We got our private key and converted it all the way to a JKS file, step by step, nothing skipped. In part 2, we will jump into ServiceNow, configure X.509 certificate, JKS provider, JKS keys, application registry, and everything that is needed to get our access token in hand. If this helped you, drop a like, that will genuinely help us. If you are hit by any problem while configuring the part 1, drop it in the comment, I will reply. See you in part 2.